Hey everybody, how you doing? Today we're going to solve multi-step equations. In order to do this, it's going to take multi-steps. It's going to take more than one step. Multi-step, hence multi-steps. We're going to isolate variables and constants, and if you know your variables, those are the things that have the letters next to it, and constants are just your plain old numbers. So let's get started. So we already talked about multi-step equations take multiple steps to solve. Our whole goal is to get the constants on one side of the equation and the variables on the other. That is the first goal. The second goal would be to isolate for your variables, so your variables all by itself. You may want a calculator, otherwise definitely have something to write with. And remember that this is a video. You can pause, you can rewind, you can go get a drink of water. You can do that because you have a video. So if you're ready, go ahead, let's get going. So this is an example of a multi-step equation. It's multiple steps because you have to do more than one step to isolate your variable. So I'm going to start by drawing a 1 in front of this x. So I know that I have 1x here. Our whole goal is to move our variables to one side of the equation and our constants on the other. Now since I have variables and letters on this, letters and constants on this side, and I just have letters, I'm going to move the path of least resistance. I'm going to move these x's to the other side. Now teachers have multiple ways of doing this. This is just one method. Know that you can do the numbers first, but this will get me the path of least resistance. I'm going to get all of my numbers on one side. So I'm going to change colors here so you can see what happens. My x's will cancel out. My positive 6 drops down. Remember that it is a positive sign. It's assumed if you don't have it. And 1 minus 4, you can add the opposite and then sing the song, same signs, keep it at different signs, I'm going to subtract. So 4 minus 1 gets you 3, and I keep the sign of the bigger one, and my x remains. Now, to isolate my variable, I need to perform the inverse operation of multiplication, because that's what's going on right here. So I'm going to divide. On both sides, I draw my division bar, and I divide both sides by whatever is next to my letter, my coefficient. I divide by the coefficient, and then my variable is isolated. It's all alone, and that is the entire goal. I want to get my variable all alone. 6 divided by negative 3 gets you 2. 6 divided by 3 is 2, but when it's opposite signs, my answer is negative. So negative 2 is equal to my variable of x, and once your variable is all alone, you know you are done. If you want to go back and check, you can always substitute in a negative 2 in for x to see if both sides of your equation are equal. So if I did that, I get negative 4 plus 6 equals negative 2, and negative 4 plus 6 equals a positive 2. So that mental math didn't work, so I had to write it down. So that gets you negative 8 plus 6. Oh yeah, that's working much better. That's equal to negative 2. So since both sides are equal, I know I solved my problem correctly. I can move on. Just like me. Let's do this. All right, in this equation, I have 2a plus 3 is equal to 3a. Again, I have variables on both sides and numbers just on one. So I want to take the variables and move them all to the same side, so I'm going to move these. So right now it's a positive. So think to yourself, how do I move a positive 2a? Pause the video and see if you can do the first step on your own. All right, friends, welcome back. I really hope you paused the video so you could do this on your own. When I started, I needed to subtract 2a in order to get rid of the a on this side. So I bring down a 3. And 3a minus 2a is 1a. If you'd like to simplify right away, just to take out the 1, you can. Otherwise, if you didn't know to do that, I just divide both sides by 1, and I'd still get 3 equals a. Either way. If you wanted to check your answer, you'd substitute in a 3 for a into the original equation. This is a good thing to do, especially on a summative assessment, which is coming up. I want to make sure I have all my answers right, so I do this in order to guarantee that my solution is correct. Since it's correct, I can go on. This looks daunting. Don't let it scare you. It just has variables and numbers on both sides. So that means you have the freedom of choice. You can choose to move your letters, or you can choose to move your numbers, or you can do them both at the same time. Just decide which ones you want to move. I personally like taking the path of least resistance, so I'm going to move the smaller variable term first. So if I were to move that first, I'd start by subtracting 3v from both sides. Now this is the part where it's really crucial that you line up the terms that are alike. So I did that. I'm going to cancel these out. I'm going to bring down a negative 8. My 7 didn't get changed, so I'm bringing down a 7. And 8 minus 3 is 5, a positive 5v. So that was the first step. multi-step, so I have to do something else. Now I'm going to move my number. So right now this is a positive 7. How would I move that positive 7 to the other side? Pause the video and see if you can figure out how to move it. Okay, if you said I needed to subtract 7, you are exactly right. So if you subtracted 7, I'm going to add the opposite here and then sing that song, same signs. I'm going to keep and add. These will cancel out. I'm going to bring down my positive 5v, making sure to look at the symbol. So when I bring it down, I don't have a negative in front of it. I just have a positive. I'm going to divide by 5 because that's the coefficient that's next to my variable. And when I am done, I'll get v is equal to negative 3. I'm going to pause and check. So what I did to check, I took this original equation, and instead of putting a v down, I replaced it with parentheses, and I put in a negative 3. So this is called the check step. This is what I did in order to check to see if my equation was correct. So when I plugged in a negative 3 on both sides and I wanted to see if they're equal, I put a question mark up here because I don't know if it's equal yet. I don't know if I goofed up somewhere. So I did this in order to maintain assurance that, yeah, I did this correctly. So negative 3 is equal to v. I'm good to go. I can move on. So this equation, again, has variables and numbers on both sides. Now I'm going to show you a different process that I use in order to make my life easier. So I have the equation written down. I know that I have less x's over here. I again like to write a 1 in front of coefficients, or if my variable is missing a coefficient, I put a 1 in front of it. Now I'm going to show you how to do this a little bit faster. So I know I need to move my variables, and I know I need to move my numbers. You can decide which one you'd like to move. It doesn't matter which one. In the end, you will have the same answer. It's just whether you want positive answers or negative answers, but in the end, your answer will be the same as long as you do your math steps correctly. So you can choose to move the 1x or the 4x. It really doesn't matter as long as you move one of them. All your letters need to be on one side of the equal sign, and all your numbers need to be on the other. So choose one. I'm going to move this guy. In order to move it, I need to subtract 1x from both sides. I'm going to do that here. Okay? And now I also need to subtract my 11. So let me show you here what happens. Sorry, trying to get my eraser. This is going to cancel out. A lot of you, it will make help if you just cancel out right away. So know that, okay, now I need to move my numbers as well. So this is the shortcut step I was talking about. And if it doesn't work for you, if it's confusing, do the other method where you bring down your 3x equals, you bring down your 11, you bring down your positive 2. This only works if you're ready for it. So those of you that are ready, here we go. Do you see how you had to move this 11 by subtracting 11? You can go ahead and do it right here. It's going to cancel out. I also need to subtract 11 from this side. And 2 minus 11 gets you negative 9. So this is one way where you can do both steps in one process, one equal bar. But I still have a multi-step equation. I still need to isolate my variable, so I'm still going to have to divide both sides by 3 in order to get my x alone. X will be equal to negative 3. And when you check your work, it'll match. This one is very long looking. Let's make it easier. So let's combine the things that are alike on this side of the equation. I can combine the 10z and negative 4z and rewrite it as 6z. And I like to write my z's with a line through it because otherwise mine look like 2. I still have negative 15, and on my equal sign goes here, and now I'm going to combine my numbers. 8 and negative 15. It doesn't matter which one you write first. I just get in the habit of writing in standard form, so I'm going to write my negative 2z first. And again, this is a z, that's why I'm putting a line through it. And negative 15 plus 8, that gets me a negative 7. All right. Now, pause the video and decide how you're going to tackle this problem. So I'm going to slow my roll, and I'm going to do this moving first. I'm going to move this as variable first. So I'm going to move the negative 2z by adding 2z on both sides. I just want to make sure I put it underneath the term that's like it. So I want to make sure it's the one with the variable. I get 8z. Bring down this negative 15. If you wanted to do 2 steps at once, go for it, and bring down this negative 7 because this cancels out. And now I need to move this guy. In order to move that, I need to add 15 on both sides. I bring down my 8z, and I set it equal to 8. When I divide by 8 on both sides, I'll get z equals 1. Pause the video. So I'm rewinding this problem, and I'm going to show you a different way to do the same problem. So you start the same way by combining like terms. But when you get to moving your variables, again, it doesn't matter which one you decide to move to which side. You can move the 6z or the negative 2z. I just think adding 2z would be easier, so that's why I chose adding 2z. But now I know I'm going to have to move this guy to the other side as well. So you could add 15 on both sides in the same step. You would still get 8z is equal to 8, and you'd still divide by 8 on both sides, and you'd still get an answer of 1. You just have more paper to work with for your next problems. If it's confusing, don't do it. Stick with what works. Here is a few special cases. So these are called special cases because, just check it out, bear with me, if I was subtracting 1g from both sides, notice that I get rid of it, and I get 7 equals negative 3. This is not true. So when you ever get something that is not true, it's called an answer that has no solutions. So you don't write not true. You instead write no solutions. There are no solutions to put in for g to make this true. You could not substitute any real number in for g in order to make this true, because once you isolate your variable, you will never get 7 equals negative 3. It's not true, so your answer is no solutions. This is called a special case. There's one more special case. Let me work through this and show you what will happen. So you start by seeing this is the distributive property needed here. So I'm going to multiply 2 by 3z to get 6z. Again, I know I write my z's a little funny. 2 times a positive 1 gets you positive 2. And look it's the exact same on the other side. So if you if you got rid of your variable, or if you get rid of your numbers first, you'll always get the same answer. This is supposed to be the same. I messed up. This is supposed to be an x. Can you please change that? Thank you. I appreciate you. All right. Now notice that they're the same. They weren't the same earlier, but that's because I made a typo. Now, if you get in the same, if you were to solve this, subtract 2 from both sides, you get 6x equals 6x, and then you divide by 6 by 6, you get x equals x. Well, yeah, if you have them the same on both sides, like a mirror image, it's called an identity. So when you get into algebra, they'll be called identities. Well, how I remember this, if you're looking in the man in the mirror, you can see yourself. And if that's true, any number you put in for x is going to make the other side true. So you write all real solutions as your answer, because any single number, any real number, all real solutions, any real number that you substitute in for x is going to make this equation true. It's going to be equal to x on the other side. Pick a number, and I bet you will make it true, as long as you fixed my goof up here and have an x. Lovely. This will be the last problem on today's video. So we have a company that charges the flat fee of $19 plus $1.50 per hour. An alternate company charges $15 as a flat rate. That means upfront, but they charge $2.75 per hour. And I want to know, in how many hours would I pay the same fee? So when is it going to be worth my while to go with one company over the other? So you start the same way. You start by getting all your numbers on one side and your variables on the other. So I'm going to start by subtracting $1.50 times h under both variable terms. So I started by getting rid of that $1.50h on both sides. So I got 19 equals 15 plus $1.25h. And as long as I remember money needs to go back in, or it's actually asking for hours, I don't need my money variable, my symbols anymore. So I'm going to subtract 15 from both sides. To get rid of that 15, I'm getting very close to getting my variable isolated. But now this is an h. In order to isolate my variable here, I needed to divide by 1.25. And remember, this was money divided by money. And so money divided by money will not have money anymore. $4 divided by 1.25 is 3.2 equals h. That's 3.2 hours. So in 3.2 hours, I would be charged the same amount. If you wanted to think of what 0.2 of an hour is, that'd be 0.2 times 60, or 3 hours and 12 minutes if you want to be technical or savvy.